Syahindah Razib, and I'll be presenting for the first question, which is integration by partial fraction. So firstly, as we look at the question, you can see that the degree of px is larger than or bigger than degree of qx. So it is an improper fraction. So for improper fraction, we need to apply long division. After we done applying long division, then we'll be applying the partial fraction decomposition. So this is how we apply long division. So firstly, we need to look at the value of x cubed, x squared, and x. So for the remainder will be 13x plus 12 over the what we divided, which is x cubed plus 4x plus 3. After we done applying long division, then we'll be applying the PFD, which is partial fraction decomposition. So there is the three type of factor, which is non-repeated linear, repeated linear, and non-repeated quadratic. So for here, we look if the type of factor is non-repeated quadratic. So firstly, the quadratic will be factorized, and then we'll look which is what type of. There is two type, which is x plus 1 and x plus 3. So there is two types. So there is two type of fractions, which is over x plus 1 and x plus 3. So we look at them, which is x plus 1 is linear, so it is a plus b. And after we get the equation a over x plus 1 plus b over x plus 3, we will equal the denominator. So both of them will times each other, and we expand the bracket, which is ax plus 3a plus bx plus b over x plus 1 and x plus 3. And then we will be factorize the x. Next, after we factorize the x, we'll compare the numerator that we get here and the original numerator. So the coefficient of x1 is equal to a plus b is equal to 3, 13, and numerator of x over x0, which is 3a plus b, is equal to 12. And then we'll just find the value for a and b. Then we'll get the value that a is equal to negative 1 over 2 and b is equal to 27 over 2. So we'll substitute the a and b value into the equation. Then we'll solve the integration function for a and b. So for 27 over 2 and negative 1 over 2 will be bring outside of the function, and 1 over x plus 3 will let you the x plus 3. So du equals to dx. So 27 over 2 is equal to 1 over u du. And for integration of 1 over u is ln u, so we'll substitute back the u function. So ln is equal to x plus 3. And for the negative 1 over 2, we'll also let u dx plus 1, so du equals to dx, and so negative 1 over 3 is equal to ln x plus 1. So the answer is x squared over 2 minus 4x plus 27 over 2 ln x plus 3 minus 1 over 2 ln x plus 1 plus c.
Hi and Assalamualaikum, my name is Aqilah and I will solve question number 2 related to triple substitution. To solve this question, firstly I identify value of a, radical form, and x. A power of 2 equal to 4 and square root 4 becomes 2. Radical form use is x equal to a sin theta because from the equation a power of 2 minus x power of 2, which refer to the formula. For x value, I wrote x plus 2 equal to 2 sin theta and substitute a value in the equation. Simplify the equation and get x value. After that, sketch the right triangle. Use value of sin theta equal to x plus 2 over 2 from equation x equal to 2 sin theta minus 2. For third step, to find dx over d theta, differentiate 2 sin theta and get 2 cos theta. Fourth step, substitute x and dx into the equation. Cut the value of negative 2 plus 2 and multiply 2 cos theta in the bracket with in the bracket 2 sin theta minus 2 plus 1. Next, bring out 1 over 3 to the front and factorize value in square root. Next, apply identities for 1 minus sine power of 2 theta. Get cos power of 2 theta. And square root the cos power of 2 theta. Get cos theta. And after that, factorize the value above. Next, integrate sin theta, and the value becomes negative cos theta minus theta plus c. For last step, substitute value of cos theta and theta, which is obtained from the right triangle. Simplify the equation and get the final answer.
Hi, I'm Jasmin. Now I will show you how to solve questions that involve integration by parts. Gear up and get ready with your pen and paper or whatever you like, because we are going to do some calculations. But before we do the question, we must know what is integration by parts. Integration by part is a technique that is applicable when we integrate the product of two functions. So the only formula we use here is integrate u dv equals to uv minus integrate v du. But before we use the formula, we need to use the method known as LIAT. So LIAT stands for, each letter in LIAT stands for like L. L is logarithmic or ln. Then I is inverse function. A is algebraic function. T is trigonometric function. And lastly, E is exponential function. There are 5 steps we need to note to solve question letter. The steps are, first we need to identify u by using LIAT. Whichever function that starts according to LIAT will be the u. Second, identify dv. Third, we need to differentiate u and integrate dv. Step number 4 is to substitute u, v, and du into the formula given above, like I mentioned before. Then step 5, just solve the function until there is no more integration and we will get the final answer. So let's see the question. Question C, integration by parts. So the question asks us to evaluate integration of x inverse secant 2x dx. Okay, now remember back what I just mentioned about 5 steps. Now let's begin with step 1. Step 1, we need to identify u by using LIAT. So I will label, my method is I will label first by underline x and inverse secant x. X is algebraic, so it is a, and inverse secant 2x is I. So from LIAT, I comes first before a, so inverse secant 2x will be the u. Step 2, since u is inverse secant 2x, dv will be dx. So now let us differentiate u. U equals to inverse secant 2x. So to differentiate u equals to du over dx. Then we can refer to the formula, which is inverse secant is equals to 1 over u square root u square minus a square. So we compare here, 2x will be the u. So 1 over 2x square root 2x square minus 1 square, we will get 2 over 2x square root 4x square minus 1. So we need to find the value of du. Then we need to transfer dx to the right hand side. So we will get, we can also cut. We can cut to the denominator and the numerator. So we will get the final du equals to 1 over x square root 4x square minus 1 dx. So the value for integrate dv equals to integrate x dx. So integrate v, we will get, integrate dv, we will get v equals to x squared over 2 plus c. Okay, so now we have done with step 1, step 2, and step 3. Now we are going to do step 4, which is we need to substitute back the value of u, v, and du into the formula. So the formula here is uv minus integrate v du. So u here is inverse secant 2x times with v, x squared over 2, minus integrate x squared over 2 times with 1 over x squared root 4x squared minus 1 dx. So we will get x squared inverse secant 2x over 2 minus, I will take out the 1 over 2 because it's easier for me to see and I think it's a better way. So I will take out 1 over 2, then integrate x squared times with 1 over x square root 4x squared minus 1 dx. Then we only look for the integration part because we need to settle this part. So x squared with denominator x, we can cut off. So left with us only integrate 1 over 2 integrate x over 4x squared minus 1 dx. So from here, we need to settle for the integration part, but it cannot be done by itself. So we need to let the denominator with u. So I will let u equals to 4x squared minus 1. So we need to differentiate u, which is du over dx, and then differentiate 4x squared equals to 8x. So dx, we will get du over dx, du over 8x. Then we will substitute back the value of dx into the solution before this, which is we will get x squared inverse secant 2x over 2 minus 1 over 2 integrate x over 4x squared minus 1 times with du over 8x. So we can cut the value of x and x. So we will only left with du over 8. So the value of 8, I will times with the outside 1 over 2. And then we will get 1 over 16 integrate 1 over square root u, because we already represent u with 4x squared minus 1. So I will just put u there. So we get 1 over 16 integrate 1 over square root u du. Okay, so until here, we actually can finish the integration already, because we only need to do integration. So no need to substitute. So we're already in the step 5, which is solve. Solve by doing the integration. Okay, so lastly, we will need to integrate the u. So how to integrate u? U plus, integrate u to the power of negative 1 over 2 plus 1. We'll get u to the power of 1 over 2 over 1 over 2 plus c. So lastly, we just arrange back. We will get x squared inverse second 2x over 2 minus 1 over 8 square root 4x squared minus 1. We substitute back the value of u into the final answer plus c. Don't forget to plus c. Then that will be our final answer, and that's all for integration by parts. I hope you will understand as you do the equation. Okay, thank you, bye.